Welcome to the Vox Pathfinder 15R channel, and today we're going to discuss the ripple current that you see on the output of the power transformer that these two large 22 microfarad filter capacitors are filtering. And you get this sawtooth ripple. And we have here the two capacitors, and we have one probe attached here and the other probe attached here. And we're looking in AC only. And here you can see where I have it hooked up on the board, and those are the rectifying diodes. And in order that I do not zap out my oscilloscope, I have a 3 to 2 prong converter on the wall over there that's isolating this chassis from earth ground mains. So I know this power transformer is in good shape, so I can do that temporarily. And this way the ground that you see on the chassis point doesn't connect to the secondary side, and then by probing it in turn zap my oscilloscope and short it out. You can do other things. You can put an isolation transformer, but this is a relatively easy fix. This is your isolation transformer as long as you lift the ground and do that temporarily. So here we're looking at it, and what we've got is 0.2 volts per division, and I have it centered within one division. So you can see that ripple is 200 millivolts peak to peak. So, I mean, is that good or bad? I mean, to me, that's a fifth of a volt. I would think it should be better. So that's these two capacitors right here, and that's the B plus, the positive, and the minus that goes to the output power chip. So here you see the B plus, and this should be the B minus, this should be the B minus, B plus to these two probes. It's powering the TDA 2030A chip. So I thought it would be an interesting experiment. I could put in a signal, turn on my signal generator, and let's see, as I turn up the gain and the volume, what happens to this ripple current. Okay, so my signal generator's up. I'm going to turn up the gain. I'm going to turn up a little bit of the volume and see how it gets affected. Look at that, people. That's just with those controls like there. Look at that ripple current. Now we got 600 millivolts, 0.6 of a volt ripple, and you got a ripple on the ripple. Look at that ugliness. And that's just the control set like so. This is with a Stratocaster. Just pumping up the volume. Look at that ripple. So we got 1, 2, 3, 4, 5. That is 1 volt of power supply ripple, peak to peak, on what should be up to 40 plus and minus 20 volts power supply on this chip. That's a lot, people, and that's only with that much setup, and we're only running a signal that would be a single coil strength, like a like a Telecaster, Stratocaster type setup. So I'm gonna, wow, look at that, even more as I pump it up more, and then bring the volume all the way down. Here I'm gonna have, the gain's like at 10 o'clock. Just look at that ripple. Holy smokes. And that's just with those settings. Okay, I hope you found that useful, and I don't know, maybe is this a good way to check whether these capacitors are healthy or not? Is this a good diagnosis? I mean, what I could do, I could put a heat probe temperature seems to be okay. So I think they're functioning probably normally, but that definitely will affect your tone. So let's just shut that down. And actually what would be interesting is, what do we got? Temperature for the power resistor. Does it feel warm to the touch? Yeah, it's getting there. Okay. All right. And of course, that's with all the power out, and it's still a fifth of a volt peak to peak. I think that's a lot of ripple. Okay, that's the Vox Pathfinder 15R channel signing out.